thanks for watching this video. So today we're gonna talk about a fan that plays music. Hello, I'm Marco and the person behind the camera is Kate. We decided to make this video to demonstrate a very simple concept, that it's possible to produce music through a fan. This is very intuitive, given that the impeller of the fan presents large surfaces that are meant to push the air forward, and if they are made to vibrate, they can easily generate air pressure that translates into audible sound. What is tricky is to control this vibration. So here we are showing a solution that uses a new inverter board from Siemens called Tapas. Full disclosure here, we received 2 Tapas boards for free from Siemens in order to work on this project as part of the Tapas challenge. So going back to our project, is that the basic idea is that an oscillation of torque in the motor translates into an air pressure wave. In an ideal scenario, where inertia of the impeller is negligible, a torque signal is converted directly into a pressure signal without distortion. Unfortunately, we have to deal with a lot of distortion in the real world, and we'll discuss them more extensively in a minute. Now I'm gonna give you a brief overview of the experimental setup. So there is an impeller connected to a brushless DC motor. They're both surrounded by a protective cage in case anything in the experiment goes wrong. And the motor is driven by the Tapas board, which is powered up by a controllable power supply. It is also connected to my PC through a JTAG programmer in order to flash and calibrate the software. And finally, one of the analog to digital converter of the Tapas board is connected through the audio port of my computer through an audio cable. Thanks to the speed of the Texas Instruments microcontroller and the software library instance speed, we managed to run the torque control loop at 30 kHz, which should allow for a decent coverage of the mid-range of the audible spectrum. So to validate our assumption that the torque oscillation corresponds to a pressure wave and to evaluate the distortion, our setup allowed to generate a single harmonic of torque at different frequency. So here I'm gonna give you a demonstration of how they sound. First of all, I'm gonna give you continuous value of torque to accelerate the fan. And then hopefully you'll manage to hear something. This is an harmonic at 100 Hz, which is almost impossible to perceive, and there's a motorcycle passing by. 200 Hz, slightly louder. 400 Hz, hopefully you can hear this better. 800 Hz, 1600 Hz, 3200 Hz, and 6400 Hz. Previously, we recorded the same data, and you can see a plot of the audio signal here. This is the audio signal at 200 Hz, 400 Hz. You can see quite a lot of distortion, but still you can recognize the sinusoidal pattern. 800 Hz, 1600 Hz, 3200 Hz. Here the sinusoidal pattern is almost unrecognizable. And finally 6400 Hz, a lot of triangular wave with different amplitude, and that's pretty much it. I mean, this effect has to be expected, given that both the motor and the impeller have not been designed for this purpose. The motor is controlled as if it had a sinusoidal back electromotive force, while it's a brushless DC, and the system is also not exactly balanced, so you can hear a continuous phase and you have some lower harmonics that can be seen in the plot. In addition to this, the impeller has a fairly large inertia. So instead of controlling the motor torque, we should really control the impeller acceleration. But the speed of the control cycle will be too slow for an accurate control in the audible range. As a final demonstration, I would like to play a song to give you a feel of how it sounds through the fan. So, first of all, I'll start the song in my browser, then I change a switch in the code. I hope you can recognize the song. It's just So this is just to show that we can actually produce audible information, and although the sound quality is not excellent, I think we can work on that through the design of the fan. But yes, I think the results of our experiment are successful. Thanks a lot for watching, and see you next time. Bye bye!